Hi dear students, in the previous video we discussed the problems on student t distribution. So in this video we will discuss the another type of examples on student t distribution. We know the student t distribution, it is t is equal to x bar minus mu divided by s into under root of n. X bar is the sample mean, mu it is the population mean, s it is the sample variance, and n it is the number of data or sample size. So let us consider one example. 10 individuals are chosen at a random from a population and their heights in inches are found to be, they are given, these are the 10 heights for the individuals. So we have to test the hypothesis that the mean height of the universe is 66 inches. So in this problem they are mentioned given t of 0.05 which is equal to 2.62, means it is a t distribution problem. Suppose they are not mentioned this one. So just you have to count the data. Data it is 10 is there, so 10 it is less than 30. So we have to apply the student t distribution. Okay. So solution. So we have the student t distribution. It is t is equal to x bar minus mu divided by s into under root of n. So by data they are given it is a universe height. Universe height. It is a population mean we can call, or population height. So it is mu is equal to 66 given, and these are the 10 data given, that is sample size n is equal to 10. And we know that sample mean x bar is equal to sum of x by n. Add all these data divided by 10, it becomes 67.8. Then after that calculate the s. So to calculate this, we know that s square is equal to 1 divided by s minus 1 sum of xi minus x bar whole square. Xi means these are the data x1, x2, x3 up to so on x10 minus x bar 67.8. So we'll get it is s square is equal to, on simplifying, s square is equal to 9.067 we'll get here. By using this one we can get the s, it is 3.011. Then after that substitute all the values in this t, that is x bar minus mu divided by s into under root of n. X bar it is 67.8 minus mu it is 66 divided by s it is 3.011 into n it is 10 under root of 10, and simplifying we get it is t is 1.89. So 1.89 it is a calculated value, and given this one t.05 is equal to 2.62, it is a table value. Okay, if the calculated value is less than table value, then we can say that the hypothesis is accepted. If the calculated value, this t value, is greater than the table value, then we can say that the hypothesis is rejected. In this problem, 1.89 is less than 2.62, then we can say that the hypothesis is accepted at a 5% level of significance. Okay. So let us consider another example. In this example, it is a comparison between the two groups. Okay. If the comparison between the two groups, then we have to remember the student t distribution. It is t is equal to x bar minus y bar divided by under s into under root of 1 by n1 plus 1 by n2. If the number of data is given, two data given, then you have to remember the student t distribution. So the problem is the group of 10 boys feed on a diet A and another group of 8 boys feed on a diet B differ. So for a period of 6 months, recorded the data increase in heights. So diet A they are given 10 data increase in heights, and diet B they are given 8 data increase in heights. So we have to test whether the diets A and diets B are differ significantly regarding their effective on increasing heights. So solution, for diet A we find out the n1 x bar and sum of x minus x bar. So n1 it is the number of samples in diet A, that is 10 given. So for this one we will calculate the x bar mean, that is sum of x divided by n1. So 5 plus 6 plus 8, adding all this divided by n1, that is 64 divided by 10, it is 6.4. Then after that, for this diet A we have to find out the sum of x minus x bar whole square. X means these are the x data, x bar means this is the mean of the diet A. We get it is 102.4. Similarly, for diet A, denote the sample size, it is n2, that is 8. Here 8 data is there. For this one, find out the sample mean. Y bar will denote, that is y of sum of y divided by n2. Sum of y, adding all this, we get 40 divided by 8, which is equal to 5. And for this one, we will calculate the sum of y minus y bar. Y means these are the data. Y bar it is 5. We get it is 82. Then after that, calculate the S square. Now S square, here two data is given, two dielects, two samples, then S square becomes 1 divided by N1 plus N2 minus 2 into bracket sum of x minus x bar whole square plus sum of y minus y bar whole square. So adding these two, okay, 102.4 plus 82, we get it is a 184.2 divided by N1 plus 10 plus 8 plus 2, it becomes 16. On simplifying, S square we get it is 11.525 and S becomes 3.395. Then after substitute all these in the student T distribution. So here comparison between the two data is there. So remember the student T distribution, it is y bar minus x bar minus y bar divided by S under root of 1 by N1 plus 1 by N2. Substitute x bar value, y bar value, then apply S value under root of N1 and N2 values. And simplify, we get it is T value 0.87. So this is a calculated value 0.87 for a given data. T value it is 0.87 and table value it is, here total data are 16 are there, 18 minus 2 it is 16 and from the table this is the standard value T of 0.05, we compare with the 5% level of significance. So for 16 degree of freedom we get it is 2.12. 2.12, this table value is greater than calculated value 0.87. It means that, or hence we conclude that the two dielects do not differ significantly as regarding their effective increase in heights.